This video will take you into the world of STEAM education. STEAM stands for science, technology, engineering, art, and math. As an example of STEAM education, we are focusing on GeoGebra and 3D printing technology. How does STEAM education apply to 3D printing? Basically, 3D printers are the most popular STEAM tool as it encourages multidisciplinary thinking. This technology can address mathematical calculations, practical engineering, problem solving, and it will help build an object for desired functionalities. The first step is to design a 3D object. For 3D object design, we used GeoGebra. GeoGebra is a free dynamic mathematics software for all levels of STEAM education that brings together geometry, algebra, numerical data, graphing, statistics, and calculus in one engine. GeoGebra comprises a large number of free tools that are available for students to explore many areas of math. By using GeoGebra, anyone can easily design 3D objects using those available tools. For demonstration purposes, we created a 3D artistic base by using mathematically well-defined curves. The first step is to simply arrange key anchoring points in whatever shape you want to be your 3D object. Then connect all your points using a common mathematical function, for example, polynomial function. Here, we used the fitPoly command with two arguments, list of points and degree of the polynomial. It will connect all the points with a polynomial curve. And then, using commands like an if-then command, surface functions, polygons, and cones, we can convert the 2D curve to a 3D object. Using the GeoGebra software, the creator is able to take simple shapes and turn them into more complex designs. In traditional manufacturing, we need complex tools, significant costs, and lots of energy and effort to design and create such objects. Using 3D printing, we are able to minimize all these things with rapid prototyping. This is the final 3D drawing using GeoGebra that we can view from all directions. The next step is to translate the 3D drawing into the computer code that the 3D printer can understand. In other words, the computer file conversion. From GeoGebra, we can perform both import and export operations to convert it into an STL file. This is now an STL file for 3D printing. For 3D printing, we just need a 3D printer with filament in a suitable STL file. We need to upload the STL file in the MakerBot Print Slicer software. After that, we get a print preview video like this in the MakerBot Print Slicer software. After arranging all the components, you can see how your design will print in a 3D printer and select the filament. We used polylactic acid as filament, which is a biodegradable one. After uploading, we arranged some components like a base layer, layer height, infill density, number of shells, and more. After starting printing, we need to examine the printer in regular intervals to make sure the 3D design is printing properly. STEAM education inspires us to explore the unknown world by bringing in different perspectives. It also helps us learn in a fun way, work with each other to solve problems, take risks, and learn from our mistakes. We believe in 3D printing's future in STEAM education and the influence it may have on the world if children are exposed to such learning as early as possible. We are committed to inspire others and making a difference in the lives of all students. If students are going through these types of processes, then they are capable of creating, designing, and printing practically anything. The options are limitless.